We have built some unique features for troubleshooting inconsistencies among sites and comparing long and short-term data into our HMI. First, the ability to open multiple site screens at the same time allows us at a glance to compare instantaneous daily min and daily max values. Comparing data between similar field infrastructure allows the user to quickly detect any anomalies. We will only open 2 windows for this demonstration, but with proper system resources, one could open an infinite number of simultaneous site windows. This is even further enhanced by our ability to compare multiple trends simultaneously, which will be illustrated shortly. Now we will look at our trending engine and our ODBC communications. Many software packages offer these features, but typically sending data at a timed interval from the host. This leaves operators searching through long-term trending datasets, trying to determine good data from bad data based on flat data or zero values. We have streamlined this into our communications driver, which writes values to ODBC after every poll that successfully reads values from site. The result, only good data, is stored in the underlying SQL tables.
Every value we read back to the host is stored in the SQL tables, providing granular, powerful raw data sets that can be organized to meet future demands. This includes min and max values as well as counts and timers on digital inputs. Even our historical polls are stored in a similar fashion to ensure quality granular data is stored for detailed review at a later time. There is no decay in granularity as there is with many systems in industrial operation today, which allows year-over-year comparisons to be conducted to assess efficiency of machines and other technical attributes. Our trending engine graphic clearly illustrates data points to eliminate human error in qualifying valid data. We also have the ability to modify the scale of each variable individually and to do the same with the timeline. Our trending engine retrieves the datasets directly from the SQL tables, so there is no change in interface between long and short-term trending.
And now a quick demonstration to place trends of 2 different sites side by side where they can still be actively manipulated. Once they are open and positioned, the datasets are relatively easy to manipulate. It is clear to see how powerful this could be in the hands of operators with a high level of technical aptitude and understanding of site control logic. This cannot typically be completed without multiple hosts or third-party software modules, so we are proud to have identified this as a need to have feature integrated into our primary software package.
Our system generates reports that can be saved or printed in various formats. We automatically generate daily, monthly, and annual reports with the same format. We will cover only daily reports as the rest is redundant. First is a report that we designed for generator controllers. There are a number of items common to all of our reports and will not be described for the remaining report types outlined. In the top left, we have the report date, followed by the report description. This is a daily report. Our file name and storage location of the raw report is in the top right. Next we have the site ID, site name, and prime device at site, as well as country, province and customer contact information. The host date and time that report was generated, as well as the contract hour rollover time, and the last documented generator control change. The last historical poll, covered by the report, as well as the first historical poll, outlines the data duration covered. We also have a value for last latched alarm reset, which in this case, was prior to the last system restart. The last and first regular poll timestamps are also recorded, as well as the last time sync poll. This data is especially helpful if the site has been offline for maintenance, or was dormant for a given time, as this may cause variations in values for timers and counters. Displayed here are the communication statistics over the duration of the report.
Let's cover the items that are isolated to the generator controller reports, such as set points, which are illustrated as they were at the end of the day. Power counters and timers analyzes the values from the end of the day and subtracts the value at the beginning of the day to derive the daily totals, recorded in this column. Power min and max values are the extremes recorded over the day covered in the report. In this particular case, it is clear to see that the utility power voltages fluctuate considerably, as seen with a minimum recorded value of 108.6 volts AC. The digital input counters are also derived from the overall counters at the end of the day, less the overall counters at the beginning of the day to provide daily totals. The digital input timers work in the same fashion, but are illustrated in minutes. The analog input minimum and maximum values are also recorded to display the value ranges for the duration of the report for the specific points identified.
Next we have a report that we designed for battery charge controllers. I will bypass the top section on site information and polling data, as it is familiar with the other reports, as is the communications section. The set points on the report indicate the values of the set points at the beginning of the report, and also displays them at the end of the report, for various points. Bank 1 min and max section are the extreme low and high values, for the entire battery bank of cells, over the duration of the report. This is further broken down into the individual strings, and their corresponding cells, to capture value ranges, that easily allow cell comparisons within the battery bank.
Last we have a report that focuses on HVAC monitoring. I will again bypass the top section, site data and polling information, as well as communication statistics, to avoid redundancy. The set points are recorded at the beginning of the report and at the end, to determine if any changes have been made during the report timeline. The min and max values, for various recorded items at site, are also displayed, to illustrate the extremes over the course of the report. The overall counters and timers are also displayed, as they were at the end of the day, and subtracted from the beginning of the day, to derive the daily total.
In the telecommunications sector, we are seeing ever-increasing use of high-definition and 4K cameras. We have manufactured our own cameras in-house, which are large and obvious, to showcase their movement on site. These high-resolution, network cameras have the ability to pan 360 degrees and tilt 180 degrees. They include a built-in 20x optical zoom, night vision, environmental controls to prevent fogging, and a host of other features. They communicate over our Skynet routers and are hosted by Infinity HMI in our data center, where they are accessed by our network operation team. On this screen we have two live view cameras. I'll open one. In the top left is the last date and time the site communicated, followed by our site ID, site name, interleave button, next poll interval, and the host date and time. We have our typical alarm log at the bottom and navigation buttons just above. In this application, we are using the camera for security and safety, to ensure that we can visually inspect a standby generator, in the event of an intrusion alarm.
In the main image area, we are displaying a medium-resolution image, streamed from a camera at a remote site. The streamed image includes the site ID and name in the bottom right, which is programmed into the camera at site. This ensures that we are actively viewing the desired site. In the top left, we have the image stamped with the local time at site, which is important for event or incident reporting, and also confirms that we are looking at a live image. This particular site has 7 scene preset buttons. The camera cycles through all of them on a timed basis. The pan, tilt, and zoom values are associated with each scene. By clicking on the navigation area, the user can take the camera off its timed routine, to control the camera manually. Focus, color balance, and even night vision are controlled automatically. Active tracking, facial recognition, subject recognition, and various AI subroutines are optional.
Here we have our standard scene buttons. At this site, we've selected 7 particular points of interest, and with the click of a button, we can force the camera to target and zoom in on specific scenes. Each camera could point and zoom at a preset scene on a daily routine, or from a triggered input, and transmit a photo or video through email, SMS message, or even file transfer protocol. We can even initiate a live stream, directly to a specific screen, to alert network operators, or security personnel. Infinity HMI has the ability to open multiple camera windows at the same time. This is important if we experience multiple simultaneous triggers, or if we want to compare sites. In certain industrial control applications, we are using these to visually inspect equipment operation, or check for chemical or fuel leaks. With this technology, we are able to expedite, prioritize, or sometimes eliminate maintenance visits. The end result is a dramatic improvement in production, safety, security, and ultimately, the bottom line.